Here is a square of side length x and we have a straight line of 12 units length. This is another line of 9 units length and the distance between these lines is 3. One of the most obvious mistakes that generally most of us do is that we think that this line if extended or this line extended will be the diagonal of this square, but that's not the case. The diagonal is the point which I can join from this point, a line that starts from this point and ends at this point. This will be my diagonal, but since none of these lines are following that thing, so they won't be the diagonal. Then how can I start thinking about this? How can I even start approaching this question? One way to think about this is a square of side length x. Somehow I need to relate this x with the given values written down here. One of the most common steps that generally most of us take is that we will join this point to this point and this point to this point. So we can get two right angled triangles. We have the length of this perpendicular as 12, this is 3. So we can find this hypotenuse. Similarly, we have the length of this perpendicular as 9, this base as 3. So we can find the length of this hypotenuse. But again the question is, how can we relate this unknown x with this hypotenuse or this hypotenuse? Because ultimately I need to find the value of x, but this is not the right way. I mean, there is no way to relate them. So I think this might not be the correct approach. Then what? Then what can be my next step? So let me remove this first because this won't help us. What can help us is that this is x and this is x. The closest I can get to these values is that if I can somehow join this point and this point, this and this point. Now this is my diagonal joining the opposite corners of the square. I know the length of this diagonal will be root 2x. The length of this diagonal, let me draw the same figure here. So let this be my square. The length of this diagonal, this is x, this is x, this is 90 degrees. So using Pythagoras theorem, I can calculate that the length of this diagonal will be root 2x. Now the moment I join them, I can see here two triangles. Let me name them. Let's say that this is A, this is B, this is my point O, this is C and this is D. So we have two triangles here, two right angled triangles AB and O and DC and O. Is there a relation between both the triangles? Can I somehow find the length of this hypotenuse DO and length of this another hypotenuse AO? Because I know that this total length is root 2x. If I can somehow find the length of this hypotenuse plus this hypotenuse, I can equate that to root 2x and find the value of x then. But again the question is how? Now what will help us is that finding the relation between two triangles that we have here. One is this triangle DOC, this one, and another is this triangle ABO. So let us think of some approach here. What we can do is that this is 90 degree, this is also 90 degree. This angle and this angle, will they be equal? Yeah, I think they'll be equal. That is angle DOC will be angle to BOA. Why? Because they are vertically opposite angles. So they are equal. Now we know that if in a triangle two angles are equal, then third angle will obviously be equal. This angle will be equal to this angle. Now in these both triangles, since all the three angles are equal, so I can say that by AA criteria, both triangles are similar. That is, triangle ABO is similar to triangle DCO. Both triangles will be similar. And if two triangles are similar, the ratio of the corresponding sides are equal. So now I know that AB upon DC will be equal to BO upon OC. I'm taking the ratio of the corresponding sides, which will be equal to AO upon DO. Now what's the length of AB? AB is 9 units divided by DC. DC is 12 units equal to BO. Now I know that this total length is given as 3 units. So let's say that this BO is some x units long. So this OC will be 3 minus x units long. So BO is equal to x divided by OC, that is 3 minus x, equal to AO upon OD. AO. Now we don't know the length of AO, neither we know the length of OA, but we know that AO plus DO is equal to root 2x. So we have an equation here. Let me write this here, AO upon DO. So using this equation, we can easily find the value of x. Actually, let's take some other value, because x is actually the side, the length of this square. So in order to avoid confusion, let's say that this is y. So this will be equal to 3 minus y. So this is y upon 3 minus y, y upon 3 minus y. So using this, we can easily calculate the value of y. Let's do that. So 9 upon 12, we'll divide numerator and denominator by 3. So 3 3s are 9, 3 4s are 12. On cross multiplication, I can write it as 3 times 3 minus y is equal to 4y. This means 9 minus 3y is equal to 4y, which gives us 7y is equal to 9, which means y is equal to 9 upon 7. The value of y is 9 upon 7. So this length is 9 upon 7, and this length will be 3 minus 9 upon 7, that is 21 minus 9 upon 7, which is equal to 12 upon 7. So now we know this length. We know the length of this perpendicular. So using Pythagoras theorem, we can find the length of OD. So OD will be equal to DC square plus OC square. Actually OD square will be equal to DC square plus OC square. The length of DC is 12 units. So 12 square plus OC square. We just calculated OC is equal to 12 upon 7. So this will be equal to 12 upon 7 whole square. This is equal to OD square. And similarly I can write OA square is equal to AB square plus OB square. Again, using Pythagoras theorem, OA square is equal to AB square, this perpendicular AB square, plus this base OB square. So OA square is equal to, the length of AB is 9 units, so 9 square, plus OB, the length of OB is 9 by 7, so 9 upon 7 whole square. So using this equation, I can write OA is equal to under root of 9 square plus 9 upon 7 whole square. And using this equation, I can write OD is equal to under root of 12 square plus 12 upon 7 whole square. Now it might look complicated at first, but trust me, the calculations will become simpler the moment we start solving it. Now we know that OA plus OD is root 2x. So now we have the time. Now is the right time to equate them. AO is equal to under root of 9 square plus 9 square upon 7 square plus DO. DO is equal to under root of 12 square plus 12 square upon 7 square, and this value is equal to root 2x. Now I can see 9 square we have in common here. So I can pull out 9 square. Under root of 9 square, remaining is 1 plus 1 upon 7 square, and 7 square is 49, plus under root of, I can pull out 12 square from here. Inside I'll have 1 plus 1 upon 7 square, again 49, and this value is equal to root 2 times x. 9 square, under root of 9 square will be equal to 9 itself, times under root of 1 plus 1 upon 49 will give me 50 upon 49, plus under root of 12 square is 12 itself, multiplied by under root of 50 upon 49. Simple calculation. Now it's just about doing the right calculation. This is equal to root 2x. Now 9 under root of 50, root 49 is 7, plus 12 times root 50 upon 7. This is equal to root 2x. Root 50 can again be written down as 9 times root of 50 is equal to under root of 2 times 25, which is equal to root 2 times root 25. Root 2, let us remain as it is. Root 25 is equal to 5. So root 50 can be written as 5 times root 2. So this will be equal to 9 times 5 root 2 upon 7 plus 12 times 5 root 2 upon 7. This is equal to root 2x. I can divide this side and this side by root 2. So all my root 2's will get cancelled. So finally this will be equal to 9 5s are 45 upon 7 plus 12 5s are 60 upon 7. This is equal to x. This is equal to 45 plus 60 upon 7, which is equal to 105 upon 7. 7 ones are 7 and 7 5s are 35. So 15. Hence x is equal to 15 units long. And this is how you solve this question. So it is a bit heavy in calculation, but once you understand how we got through the core concept of using similarity and Pythagoras theorem, we can easily solve this. The only thing of thinking was to find the two similar triangles and using similarity and Pythagoras theorem, getting to this equation and then solving it.